Welcome to my mini unit on organic chemistry. I'm Ms. Heischer. This unit will introduce you to the bare basics of organic chemistry. It is not intended to replace the unit in your chemistry textbook, but more as a heads up for science students who have not yet taken chemistry. I've found that many biology and other science textbooks mention these terms, but without defining what they are. This, then, should help you when encountering these unfamiliar terms. Let's talk about exactly what is organic. Again, the term in familiar usage is not the same as the term when used in science. By what I mean again, I mean theory. Theory in modern usage in the CSI drama is not the same as theory when it's used in biology. Organic's the same way. Organic at Kroger is not organic in biology. It does not mean that this was created without the use of pesticides. So what does organic mean in science? The use of the term organic dates to the 19th century when it was believed that organic molecules could only be derived from living organisms. Organic molecules are molecules that contain carbon bonded to hydrogen. Organic molecules may contain other elements as well, especially oxygen, nitrogen, and a few other elements. What is organic chemistry? Organic chemistry defines life. Just as there are millions of different types of living organisms on the planet, there are millions of different organic molecules, each with different chemical and physical property. So you are an example of a living organism. On you, there are millions of organic chemicals. Your hair, your skin, your fingernails, that's all what organic chemistry is. It's the chemistry of carbon compounds. You could also say it's the study of compounds containing carbon that is chemically bonded to hydrogen. You could also say it's the study of molecules containing the carbon-hydrogen, that's the CH bond, and their reactions. You could also say, and be perfectly correct, it's a subdiscipline within chemistry involving the study of carbon-based compounds, which is the basis of almost all earthly life processes. Why is organic chemistry important? Well, it's the study of life, the chemical reactions related to life. That's why it's important. Well, why carbon? What's so special about carbon? What does carbon have to do with life? Well, life on Earth depends on carbon. It's present in every living thing. So why? What's so special about carbon? Well, let's take a look at this periodic table. And in this periodic table, you should see carbon. Let's see, right here is carbon. Now this 6 for a neutral atom, that tells you how many protons. It has 6 protons. For a neutral atom, that means it also has 6 electrons. 6 electrons, 2 go in the innermost orbital, which leaves 4 to form bonds. They call valence electrons. So you have 4. Each electron can form a bond with another atom, so that allows you to say that carbon can form up to 4 bonds with 4 other atoms. Common bonding is carbon to hydrogen. We call that hydrocarbon. This is called a ball and stick figure. That's a carbon atom, and this is a hydrogen atom. This is just a model. This is not what it looks like in real life. There are no sticks. Stick right here actually stands for electron. The electron is really being shared. It's a covalent bonding going back and forth, and you can't tell where it's at any one time. So just to show you, so you have something to look at, it has that stick there. Carbon to carbon bondings, I mentioned before, carbon atom can bond with 4 other elements, including itself, carbon. These form stable bonds, very common in nature. Notice this diagram, the ball and stick models of various types of hydrocarbons. Again, the black line denotes the sharing of electrons. The majority of hydrocarbons found naturally occur in crude oil, where decomposed organic matter provides the abundance of carbon and hydrogen, which, when bonded, catenates to form seemingly limitless chains. You do have a lot of hydrocarbons throughout our bodies also. They aren't as simple as what we're seeing here though. Crude oil, it is as simple as what you see here. The double and triple bonding types of hydrocarbons are referred to as unsaturated. So what am I talking about here? Notice this carbon can do 4 bonds. Notice this has 1, 2, 3, 4 atoms connected to this one carbon atom. You have 1, 2, 3, 4. It is what they call saturated. No other atoms can be bonded to that carbon. It's fully saturated, it cannot hold anything more. These other bonds are what we call unsaturated. It's a double bond and this triple bond. And that's because if you knew how to, you could come in here and you could cut that bond, and that would leave this free to soak up even more atoms. Just like a sponge, if it's saturated, it cannot hold any more. If it's unsaturated, it can hold more. Well, this is unsaturated when it's got the double bond, because that can be broken and that can be connected to another atom. So these two over here, the double bonded and the triple bonded, are considered unsaturated. The types of bonds you're seeing here, the single, the double, and the triple, are called linear bonds, and we're going to see an example of a ring. Three hydrocarbons shown here are ethane, ethene, and ethylene, and we'll talk a bit more about the naming scheme used later. I'm going to show you an example of a chain. Here is one right here. Notice that carbon is connected to that carbon, connected to that carbon, and it can go on and on. This has 6, so it is considered to be hexane. There's only single bonds, and we're going to go into that little naming scheme there in just a minute. But this is what they call a chain because they are connected to each other. In addition to the chains that hydrocarbons can form, oh, by the way, before I go to the next slide, would you say this is saturated or unsaturated? Why do you think it might be saturated or unsaturated? If you were thinking that, well, each one of these has 4 atoms. See, it has 1, 2, 3, 4. So that means it is saturated. There's no double bonds that can be broken and reform with another atom. Here's another type of chain. This is what they call a branch chain. There's the main branch. But then off of this one is another carbon atom. Would you say this is saturated or unsaturated? Ask yourself, does it have double or triple bonds? Right here, it has that carbon atom right here. We'll take a look at it. It has 1, 2, 3, 4 atoms already bonded to it. It cannot hold any more, therefore this is saturated all. And then here's your ring. Carbon atoms can form rings, very important in biology. Is this saturated or unsaturated? Take any one carbon and 1, that's your carbon atom. There's 1, 2, 3, 4. So this would be saturated. There are no double bonds, triple bonds that you can break and reform with another atom. This cannot hold any more atoms. In summary, organic chemistry is the study of molecules with carbon bonding, especially hydrocarbon bonds. Carbon forms 4 bonds, including to itself. Hydrocarbons can be in linear chains, branched, or rings. And then we also discussed about saturated versus unsaturated, meaning can it hold any more atoms, or are there only single bonds, so it can not hold any more atoms. The next video, not this one, but the next video, we're going to talk a little bit about drawing and naming simple hydrocarbons. There are lots of rules and conventions used in biochemistry, but we don't need to go into many of them just to understand what you're going to be seeing in your biology and your other science textbooks. In the meanwhile, please enjoy these famous chemists. We have George Washington Carver on the right, known for his agricultural advances. And then we have Louis Pasteur. He did some disease investigations, especially in prevention of diseases. Got milk? Well, then you got pasteurized. All milk is pasteurized in the United States. And lastly is Rosalind Franklin over there to the left. She took great pictures of X-rays for DNA. Excellent stuff. I hope you enjoyed this and that it helps you when faced with organic molecules.